I want to say that we acknowledge that this virtual presentation is taking place throughout the unceded territory of California, which is home to nearly 200 tribal nations. In particular, today I'm speaking to you from Pomo ancestral land. We acknowledge and we honor the original inhabitants of our various regions, and we encourage you to learn which tribal nations are indigenous to your area where you're living. One excellent source of information is Native Land, and we've dropped that link into the chat for you to explore later if you're interested. And with that, I'm going to welcome our speaker. Our speaker today is Dr. Emily Fairfax. She's an assistant professor of environmental science and resource management at Cal State University Channel Islands. We, and perhaps some of you, learned about her work initially because she created this wonderful stop motion beaver video and sent it out on Twitter, and it went completely viral. It was one of the most creative science communication and outreach tools we've ever seen a scientist use. And we've been a fan ever since of her work. So stay tuned for that video. Dr. Fairfax has been passionate about science since she was 3 years old. According to her mom, she told her that she wanted to walk on the rings of Saturn, but not to worry because she'd bring a car seat to be safe. Her passion for scientific discovery and exploration, thankfully, has not waned since those early years. And her current okay, sorry, I think I keep getting muted here. Not sure what's going on. Can you hear me? Yeah, okay. Her current research focuses on the ecohydrology of riparian areas, so particularly those that have been impacted by beaver damming. She also has an interest in geoscience education research and curriculum development, and she takes a really active role in training, mentoring, and teaching the next generation of scientists. And she's sought out extensive training in diversity and inclusion in academia and active learning strategies. So with that, we want to welcome you, Dr. Fairfax. Thank you for joining us today, and go ahead and share your presentation.
Thank you. Thank you for that excellent introduction. It's a story that my mom always likes to share with anybody who'll listen. And I was like, you know, I want to share this story too, because it's just kind of fun. So I am assistant professor at Cal State Channel Islands. As you all heard, my pronouns are she, her, and I am on Chumash land. And today I'm going to be talking to you all about beavers and some of the really incredible things that they do in our landscape, and especially how that relates to things like fire, which at least down here is very much pressing on my mind given the high winds and dry conditions. So I'm hoping everybody can see my slides okay. The title of my talk is Smokey the Beaver, Can Beavers Prevent Wildfires? This is work that I completed largely with one of my undergraduate research assistants, Andy Whittle, who I worked with a couple years ago when I was back at University of Colorado Boulder. So it's not exactly brand new news that beavers might be one of our allies in climate change. In fact, it is news that we have seen in the headlines over and over if you're looking carefully. So beavers, are they humanity's natural ally in combating climate change? Are they preserving our wetlands in water-stressed areas? They might even save cities like Los Angeles from droughts and floods, big ask from these little furry engineers. They make our deserts bloom, and they could save us from a dry future. It has even been hypothesized that beaver restoration would reduce wildfires as long ago as in 2013. And the research that I've done and that I'm going to talk to you a little bit about today will hopefully convince you that not only could they reduce wildfires, but in fact, beavers have become North America's best firefighter. So first off, I want to just take a little step back and talk about why Smokey the Beaver. I get that question a lot. Most of us have heard of Smokey the Bear or Smokey Bear. He goes by many names, but Smokey the Beaver is not necessarily a household name yet. So why Smokey the Beaver? Why am I treading on Smokey Bear's toes? So I started off looking into the history of Smokey Bear a long time ago. And I found some of his original outreach materials, if you'd like to call them that. I do not like to call them that because I don't find them to be particularly good outreach. It's very unfortunate, some of these. So he's pointing at these fires and he's saying things like our most shameful waste. You know, you can stop the shameful waste. It weakens America. One careless match, is it yours? And he's got like these little Bambis in his arms, and the little baby bears got their little knapsacks that they're carrying away, and they're crying in the background. And it's just like, this isn't a good message. This is not how we should be thinking about wildfires. Wildfires are natural. Wildfires belong in this landscape. What does not belong is these super mega gigafires and these extreme fire events. But painting wildfires across the board as negative isn't what we want. And furthermore, referring to all wildfires as a shameful waste and saying that this is entirely humans' fault isn't really going to change anyone's behavior. So Smokey the Bear, he comes in, he's got this fire prevention focus, right? Only you can prevent forest fires. We've all heard it. It's not a new phrase for many people. He relies a lot on human intervention and behavioral modification. And as an academic who sits in on many faculty meetings, I can tell you that modifying humans' behaviors is hard. It's hard to get people to change their minds. It's even harder to get people to change their actions. So any kind of a sort of landscape conservation approach that we take, if it relies a lot on humans, it's going to be inherently tricky. And as I mentioned, he's got this very outdated all or nothing approach to wildfire, right? It's horrible. It's a shameful waste. We don't want it. You have to stop it. I just don't think Smokey Bear's method and his messaging is very useful anymore. And so instead of Smokey the Bear, I'd like to introduce our hopefully newly embraced fire mascot, Smokey the Beaver. So Smokey the Beaver takes a different approach. Beavers can naturally moderate wildfires, and that's what I'm going to talk to you quite a bit about today. He's got this nice fire moderation focus. It's not about stopping fires, it's about moderating fires, right? Fire is natural. We want to be able to adapt and preserve sensitive ecosystems, but let the natural fire behavior happen. Smokey the Beaver works totally independently of humans. In fact, he works better without humans. So that's always a good news for me when I think about conservation, because if this is a natural process that can go on without us, it's going to be more sustainable. And then Smokey the Beaver is all about protecting sensitive riparian ecosystems, again, without suppressing that natural fire behavior. So riparian meaning streamside, these are our wetlands. These are the places where we have fish and frogs and birds and small mammals all coming together around the watering hole, so to speak. And those are the ecosystems that should not be burning historically. And yet we are seeing them burn. The river bottoms have burned many times in the last few years, and that's concerning. But Smokey the Beaver can help. So how exactly do beavers change the landscape? Let's take a step back to Beavers 101 before we dig into their firefighting abilities. So beavers have four main sort of functions in the landscape. They chew down trees, which some of us may consider to be a fuels management program. They build dams, which are inherently leaky and not particularly similar to large human-built dams. They create ponds, and then they dig channels out from those ponds. All of these behaviors together creates a landscape kind of like what you see here. So in the front, we've got this beaver's lodge. It is essentially a big pile of sticks. The beavers have gone in and they've chewed out a little room, and that's where they hang out. That's where they live in. This is the structure that beavers occupy, not the dam. So the dam, a lot of people think beavers live in the dam. They don't. The dam is built 100% out of sticks and stones and mud for the purpose of creating a pond. So why do the beavers need a pond? Well, if you've ever seen a beaver on land, they are not unlike seals on land. They are quite round. They have a hearty amount of body fat, and they are not particularly swift. And so a beaver on land waddling through the landscape is kind of like a great big chicken nugget for predators. So that's not a good situation. And over the last several million years that beavers have been on this continent, evolution has made it so that they realized if they have these nice large ponds around their home, like a moat, they're safer. These beavers can survive longer because as soon as you put that big land blubbery beaver in the water, suddenly they're exceptionally agile. They are slick, they're like otters. They can hold their breath 15 minutes. They can swim with incredible dexterity. And so beavers in the water, they can escape essentially any predator. Beavers on the land, not so much. So the whole reason they build these massive, massive dams is to make a pond to keep themselves safe. Now, as they're chewing down trees, you might imagine that in short time, the trees right around the edge of their pond are chewed down, and then they don't have trees. So what they have to do is venture further out in the landscape. But remember, they're awkward on land. So when they're on land and they're going out in the landscape, they dig these channels. And these channels are, a couple feet wide to maybe 3 or 4 feet wide, and as deep as the beaver wants them. But the whole point is that they fill with water from the pond. And so as these channels go out into the landscape and fill with water, they act like little water highways, both for the beaver, but also for the trees they chew. So when a beaver chews down a tree, as big as they are, and up to 100 pounds, hauling a whole tree over land is challenging. But if they can drag it into a channel, the natural buoyancy of that tree causes it to float. And so they can float that tree home, which is so much easier. And so they've dug these channels out for the purpose of getting themselves and getting the building material through the landscape quickly. But in doing so, they've spread water out throughout the whole landscape. They have created these vast zones that are soggy and hydrated and have essentially little irrigation channels running out through them. And so if you take this view of a beaver pond fully developed with the dam and the lodge and the channels, and then look at it from above and compare it to a stream without beavers, they are really hydrologically unique. Like the water here is different than in an undammed stream. So on the left here, I'm showing you a section of Maggie Creek, which is a creek I studied in northeastern Nevada that does not have beavers on it. You can see the creek kind of running through this landscape. A little band of green around it is the riparian zone. Single channel, not super complex. This is a section of Maggie Creek, so same creek, but it has beavers on it. And there is so much going on here. You can already see this looks different than the stream without beavers. But if you don't look at satellite images of beaver dams all day, I mean, you should, and after today, you should be able to, you might not know what you're seeing. So I'm going to highlight some key things for you. So in yellow, you're now looking at the main creek channel in both of these images. But on the right, you'll see there's a lot more. Highlighted in this sort of reddish color is the beaver dams throughout this landscape. There's quite a few of them. Highlighted in blue are the beaver dug channels that I can see from satellites. So there's probably a lot more than what I have highlighted here. And my experience in the field tells me there are a lot more than what I have highlighted in blue. These are just the biggest ones that I can see in the satellite imagery. And then circled in pink here is the beaver's lodge itself. And there's really only one active lodge that I can see in this picture, which indicates to me there is one family of beavers, 2 adults and anywhere from 2 to 6 children at home, maintaining this entire landscape. All of this complexity is being maintained by not that many beavers. So it doesn't take a lot of beavers to massively change the landscape and slow and spread and store water all around. And in doing so, that one family of beavers has the potential to buffer droughts. And so the first thing I want to talk to you about before we get into the fire is the condition that leads up to fire in most cases, and that is a drought. We, as a species, tend to really enjoy vegetation. We like trees, people like meadows, we like being surrounded by greenery. But when you have a drought, all that greenery goes that kind of classic crunchy golden brown color and becomes dry and becomes kindling. But if beavers can prevent that, then maybe they can prevent it from burning in the long run. So let's go back to these images I just showed you, except now I've added a white bar onto both of them. So what I'm going to do is I'm going to take a cross section looking down into the earth. So at the top of the image, you're going to see the plants, and then we're going to look down into the soil and see how exactly these beavers are storing water. So in our stream without beavers, we've got a bunch of plants cruising along here. They've got their roots dangling down into the soil. We have a deep water table, which is common throughout California and the American West in general. And that deep water table, that is because when it's dry, your groundwater sort of just sinks down lower. It can be higher if you're right next to the river, and that's kind of what we are seeing here. This stream is impacting the groundwater system. It is putting some water in. This is pretty common in what's called a losing stream, so it adds water into the groundwater system instead of being fed by it. But luckily, we have infiltrating precipitation. So rainwater comes down and it's, feeding all of these plants water. They're happy. Doesn't really matter that we have a deep groundwater table because all of these plants have water. It's raining. It's green. So that's great until we have a drought. So in a drought, what happens is you take away that precipitation. And when you take away precipitation, the plants that can't access any groundwater are going to wilt. They are going to go this golden brown crunchy color. They're going to dry out. They're going to senesce. And so any vegetation that was green and can't reach the groundwater is now not going to be green anymore. And that is where we start to see problems, right? That's the vegetation that's going to burn if we have some sort of a fire event. But in our stream with beavers, it's a little bit different. So with beavers, we have the infiltrating precipitation when it's rainy. We have a lot of groundwater storage because there's this huge pond. There's all these little channels they've dug that are like irrigation channels. Everything's super soggy, but again, it doesn't matter because we have rain. But as soon as you take that rain away, as soon as we enter that drought condition, only the plants that can reach groundwater are going to stay green. But luckily, because of this large pond, because of all of these channels routing that water throughout the landscape like irrigation canals, there's a lot of groundwater available. And so all these plants can reach the water. They're fine. Maybe a couple on the fringes are going to start to wilt and senesce, but this has created a large sort of drought resistant portion of the landscape. So now I've put them side by side for you to just look at them and compare again. The stream without beavers and the stream with beavers during the rainy times, it doesn't really have a strong difference if there's beavers or not. But as soon as we enter that drought, things look kind of sketchy when we don't have beavers. It starts to really dry out. So this is my conceptual model for it, but like, what does the science say? Does this actually happen? Is this more than just something that I made up and drew and talked to you about? And the science says yes. So this is Maggie Creek and Susie Creek, a satellite image of them. In the middle, we have some sparsely vegetated hill slopes. These are hydrologically disconnected from the streams. And so the hill slopes are entirely reliant on precipitation for their water source. Many of us, if we look out to the hills around us, we'll see some of these kinds of hill slopes. They're the ones that as soon as the rain starts, they go green. And as soon as the rain stops, they go back to that sort of yellowish color. And then down here, there's an irrigated alfalfa field. This will come into play again shortly. And this is the town of Carlin, Nevada, for those of you that would like a little bit more grounding of where we're looking. So if I'm looking in an actual landscape, trying to see, okay, during droughts, do the beaver dammed areas stay greener? Do the plants stay healthier? I'm going to use satellite data to answer that question. And the first thing I'm showing you is evapotranspiration, or ET, which is essentially water cycling through the landscape. It's a combination of evaporation, so like off of a pond surface or off of a puddle, but also transpiration, so plants going through photosynthesis and having water move through them. And so red indicates that not much is going on, hydrologically speaking. Blue indicates there's a lot of water cycling going on. And so we see some patches of blue throughout the landscape, some big one up here, big one down here. Remember, this is our irrigated alfalfa. This is Maggie Creek over here, Susie Creek over here. And it looks to me like, you know, there's some patches that are doing all right. And this is July 2014. So this is a drought period. And in this location, 2014 was also a drought year. So it's during the hottest, driest part of the year in a drought year. So very dry. The other data I look at is NDVI, which is normalized difference vegetation index, but you can just think about it as the vegetation greenness in the landscape. And so again, we can see very clearly some parts of the landscape are very green, which is indicated by blue. And then some places are not so green. Now, I do want to point out that these are the areas that have beaver damming in them that I've circled for you now. And you notice that the entire creek does not have blue on it, but in these beaver dammed areas, there's a lot of this blue color in both ET and NDVI, which is indicating that in this landscape, there's a lot of water cycling going on and a lot of green plants in these beaver dammed areas. Now this plot has a lot going on, so I'm going to walk you through it. Don't be overwhelmed. So on our y-axis, we have the ET. So if we're down here in these low values, that means that the plants aren't really doing much photosynthesis. They've kind of shut down for the season. If we're up in this high area, we've got these really lush green plants, water's moving through them, and everything sort of in between. Now in this gray color is the maximum modeled ET. So given the weather, given the sunlight, this is the maximum ET we would expect to see in the landscape. It normally follows this arc-like shape because the growing season is kind of an arc, right? The sun starts getting more and more intense as we move towards summer and then less and less intense as we move towards fall. So we expect to see an arc shape. On the x-axis, we have 4 different years of data. So we have 13, 14, 15, and 16, 3 years that were a pretty severe drought, and then 1 year that was normal. Normal is in big old quotes because this is northeastern Nevada, so it's very dry, even in a normal year. Whoops, but a little bit wetter. And so in green here, I'm now showing you the irrigated alfalfa fields. So this is humans managing the landscape. We're managing the water. We are putting sprinklers on these plants. We're trying to keep them as green as possible. And you can see this arc in the alfalfa, it follows pretty close to the ET that we modeled. So that makes sense. You know, we're doing everything we can to keep these places green and lush. And then right below it in blue is our beaver dammed riparian zones. So it's arcing pretty well. It follows the seasonal arc. It's less than the irrigated alfalfa, which makes sense. This is a riparian zone and these are beavers. It's not a farmer managing alfalfa, but it's pretty good. Then we come down to the riparian zone that doesn't have beaver. So this should have access to water. Most of these creeks should have stored enough groundwater or have enough groundwater in the area for a lot of this vegetation to stay green even during the summer. But what we're seeing with these increasingly common droughts is that they don't. Groundwater is being depleted. The rain is not coming when it should. It's coming in less amounts. And so in the riparian zone without beaver, we don't even see a seasonal arc. As soon as we start the summertime, these plants wilt. They go dry, they go crunchy. That habitat stops being as functional because there's not green plants in it anymore. In fact, they look quite similar to the hills and non-creek vegetation, which we do expect to go brown and crunchy every summer. So this is interesting. What's even more interesting to me is that in our normal year, you can see that the non-beaver dammed area did try to do an arc. So it can have higher ET, but it was really affected during these drought years. It just plummeted. It's like as soon as the sun came up and it should have been growing at its max potential, these plants just wilted. And so all in all, what you've seen here is that the beaver dammed areas, they stay green during droughts, whether that's a seasonal drought, like it's hot and dry in the summer, or if it's a multi-year drought. We had 3 consecutive years of drought in this data set, and the beaver dammed areas, like they didn't even notice. Beavers didn't even know there was a drought. Everything was still green, still lush, still wet. And that's really important when we think about fire. So before I move on to the fire, just going to summarize what we learned about the droughts. So when you have beavers in a stream, you'll see more ET. You'll see the plants using water, cycling water, staying green, staying lush. When you have beavers, this streamside vegetation, it's not sensitive to droughts. So you can expose it to a long-term drought. You can expose it to your seasonal drought. It stays green. It gets greener. I was in Atascadero, California over the summer quite a bit, taking photographs of a beaver complex starting in May and going through November, trying to see how the vegetation changed throughout the season. And from May to, I think, September, there wasn't like a single drop of rain, maybe all the way into October. But the plants just kept getting greener and greener and greener around the beaver dammed areas. It didn't notice that everything else was dry. And they're a lot more similar in sort of how they respond to drought to an irrigated crop. So you can kind of think of beavers as little irrigation managers. They're out there, they're digging these canals, they're spreading that water out, they're irrigating the landscape and keeping it green, even if the outside conditions are not favorable. Stream without beavers, the opposite is true. The plants wilt. They are very sensitive to long-term and short-term droughts, and they're more similar to these hydrologically disconnected hill slopes, which they shouldn't be, but they are. And so beavers are doing a really important role here of restoring these streams and these wetland areas to a more stable and more resilient state. And that's really important when we start thinking about the climate extreme that follows droughts and is more stressful than droughts, and that is fires. So beavers can create refugia during wildfires. They can create patches that don't burn. And we're going to start off again with just a little conceptual model of how that works. So we had this model we were looking at before. We've got our stream without beavers, our stream with beavers during the wet time, during the dry time. And then, you know, all of this vegetation that's gone crinkly, like that's kindling. That's what's going to burn when you have a fire starting event. And so when you have that one careless match, or in many of our cases, that one careless power line, and a fire ignition event starts, you'll get vegetation burning. But wet vegetation is hard to burn. That's just vegetation physics. Water doesn't burn easily. It's wet. It takes a lot of energy to burn through a wet landscape. If you've ever tried to start a campfire, you don't go out and pick up the wettest, soggiest leaves and wood you can. You go look for dry stuff. It burns easier. And so in these streams without beavers, there's a lot of dry stuff. And it's dangerous because when you have the rain, this is really fertile soil. It grows a lot of vegetation, but a lot of vegetation that dries out becomes a lot of fuel. These beaver dammed areas also grow a lot of vegetation, but it doesn't dry out. So it doesn't really ever become fuel in the same way. So this is the conceptual model that I have and that I, show people when I'm trying to explain, this is why beavers can fight fires. This is why they can help with droughts. But sometimes you just need like a different kind of conceptual model. And so for that, instead of turning to figure making softwares, I turned to felt. And so this is truly my original conceptual model for how beavers can fight fires. It's okay, you made it, yay! So this is what I originally thought of in my head, and then I was like, all right, let's actually like go down into the water storage. But this is what I was seeing. This is what I was thinking of when I thought about beavers fighting fires, and there was so little science done on it that it was kind of daunting to start this project. But it made so much sense that I knew I had to pursue this. And so the first question I asked was, okay, has this actually happened then? And the answer to that is yes, it has happened beyond my felt and corkboard. In 2018, the Sharps fire burned in Bow Creek, Idaho, and Dr. Joe Wheaton, who's a professor at Utah State University, was up there doing some research, and he flew his drone and took some pictures of this creek that had beavers on it. And what you can see in the front is that there's this just bright green patch in the landscape, and there's basically charcoal on either side. And the reason this patch is so green is that we are actually looking at a beaver complex. So the dam, one of the dams runs right along here. We've got a big pond, we've got some channels dug around, and you can see it's green, it's fine, it didn't burn. Landscape around it, burned. Upstream, where there weren't some beavers, I believe that's downstream where there weren't some beavers, also burned. And so we have seen this happen. It has been observed beyond the felt. This has been a phenomena that occurred in real life. So my next question is, okay, it happened once. Does it happen again? Is this repeatable, right? Science should be repeatable. Beavers should be able to do this in many creeks, in many fires, not just once. It can't be a one-off event. And so that's what I wanted to study, and that's what I did start studying and looking into. So this is the science that I did most recently on it, and it's what I'm most excited about right now. So the way that beavers actually create wildfires and what I saw in the data. So I looked at 5 different fires in my study in California, Colorado, Idaho, Wyoming, and Oregon. I chose these fires because they were large. Many of them burned somewhat out of control based on the reports that I read on them. I also chose them because I use remote sensing to do most of my research, which is satellite images. And these fires had images available that were high quality and were not obscured by smoke during the fire, which I needed. So in these 5 fires, what I essentially do is I look at those same kind of metrics, the evapotranspiration and the plant greenness, the NDVI, but I looked before the fire, so like in July of the year before the fire, and then during the fire, so if the fire burned in July one year, I was looking like during the fire, and then again after the fire. And so in doing that, I wanted to see how did the vegetation sort of fare through the fire? What did it look like before it burned? What did it look like as it was burning? And then what did it look like afterwards? So since I'm in California, and this is the California Naturalist program, I'm going to talk about the Mantor Fire in California. This burned in the Domeland Wilderness, which is part of Sequoia National Forest. It burned in the summer of 2000, and the burn area was about 79,000 acres. This is a really cool fire, in my opinion, a very cool area. Up in the dome land, there's a lot of very rocky landscape, but also some pine trees. And then through the middle of it runs the Kern River, which has a nice broad riparian zone. The other thing that's really cool about this area is it is full of beavers. Like a lot of beavers are up here, and they're still up here. This is me. This is a beaver dam. I'm up in the dome land wilderness. This was October of 2019. And these beavers have been here a long time. This is a satellite image that is from the dome land wilderness, and this is a beaver complex. And these beavers have been in this area since at least 1994. I assume much, much longer, but 1994 is the oldest high quality aerial image that I had access to. This is me trying to find the beaver dams on the ground. We're going to talk a little bit more about finding beaver dams shortly, but it's kind of interesting because you can know exactly where one is. Like I can find them in these satellite images and know, okay, I got to go right here to see the beaver dam. But actually getting them is hard. Like there's a lot of vegetation around these things. It's kind of impressive how many plants and animals can all be fit into such a small area around the beaver dams. So this is the Manta fire. It was a huge fire, 79,000 acres. And whenever I start doing this kind of research on fires, it's very easy to get caught up in sort of the data and the numbers, right? Big fire, scary fire, lots of flames, lots of beavers, and sort of lose sight of what it's like when these fires are actually burning. So I always like to go back and try to find some news articles from during the burn period. And this is a quote from the LA Times, August 2nd, 2000, about the Manta fire. It is a humbling expression of nature, walls of flame 70 feet high, twice as high as the nearest tree. Leaping through canyons and valleys, at times in 5 directions at once, left behind, quite literally, is scorched earth. And so it's easy to sort of look at the data and think about my conceptual model and be like, oh, of course the beavers made it. Like that, let you see the felt, it makes so much sense. But like these are 70-foot walls of flame. That's not trivial. Scorched earth is not just an expression. You can actually burn the soil, and that is also not trivial. That is an extreme fire behavior. And that is something that happened in the Manta fire. And so I was kind of thinking like, uh-oh, I put the eggs in the wrong basket. Like, I don't think the beavers are going to make it through this one. But I didn't want to stop the science and give up. So I continued on looking at the data. And this is what I saw. So we have the Manta fire on the left here. Its burn area is outlined in black. We're looking at NDVI, which is, again, the greenness of the plants. Anything in blue is lush, dense plants. Anything in yellow, the plants are still alive, or maybe they're like kind of sparse. If it's red, there's not really any plants there. They're dead or gone or never were there. You see a lot of red out on this edge. That's because it's the desert. So this is July of 1999 before the fire. I've sort of blown out the Kern River on the right so you can see it more closely. It runs through this landscape. And these got lots of little blue patches on it. It means there's lots of these patches of this super healthy, dense riparian zone. This is great. And then the fire comes and it burns. And we see a lot more of this red color, including through the Kern River. So the river bottom of the Kern burned in many places during this fire. Then after the fire, everything springs back, which is great. A lot of these ecosystems have evolved to be able to spring back. What has not evolved quite so easily is when we have really fragmented populations of sensitive species like fish and amphibians and birds and small mammals that cannot escape these large fires. If you burn through all the habitat, even if the plants can spring back afterwards, what happens to those animals that cannot escape? And so what's really cool about the beavers is not that they make recovery easier after fire, it's that they can create these refuges. They can create these patches that don't burn during the fire. And so in order to really sort of quantify this, imagine you're walking along a creek in my study area, and you're just cruising along from a start point to an end point. And then you stay as close to the river as you can. And at every point, you take note of how green the plants are and if there are any beaver dams or channels nearby. This is essentially what I did, except instead of actually walking along the creek back in 2000, before, like when I was still a child, I did it with satellites. So I went back to the satellite images from the year 2000, and I walked along these creeks and measured how green were the plants and where are there beaver dams. And in doing so, I can create a plot kind of like this. So we've got the plant greenness on our y-axis. So higher number means there's more green plants. Lower number means there's less or fewer green plants. And then this dotted dashed yellow line is the minimum NDVI that we would expect from a healthy riparian zone, 0.3. So below that, it's probably not doing so hot. Marked on the x-axis in black are the beaver dams themselves. And then our data shown here in 2 green colors and then this reddish color, reddish brown, is the NDVI for the different years. So before and after the fire are in green, and then during the fire is this brownish color. And you can see for a while, all 3 of the years kind of pile on top of each other, and then boom, it drops off. And we're below that dashed line, and that's not good. And it's mostly during this red color, which means it was during the fire. So for a while, the fire didn't seem to be affecting the riparian zone, and then it drops off, and the fire really affects the riparian zone. And it looks like that kind of correlates with where the beavers are. To make that more clear, I'm now showing you the difference between the pre-post average, so the greenness we would expect in the healthy times, versus the fire greenness. And so if the number is small, that means it was less affected by the fire. If the number is large, that means we were more affected by the fire. Originally, where there's beaver dams, the fire is not doing much. As soon as we get out of that beaver dammed area, we see a lot more fire damage in the riparian zone. And so this, to me, is saying like, okay, there's a strong relationship between these beaver dams and the way that the whole riparian zone is responding to fire. And I didn't just see this on one creek, I saw this on all my creeks, but don't squint too much to try to look at this image. I know you can't read these plots, that's fine. It's just for like the visual punchiness. But as I can't have you expected to read all this, neither could I have the scientific community expected to read all this. So instead of presenting my data as a bunch of these sort of little spiky plots, what I did is I synthesized them all together, and I looked at all of my creeks, and I classified all of my pixels as either being affected by beavers or not affected by beavers. And then I compared the areas with beavers to the areas without beavers across all my fires, across all my creeks, all the data, put it all together. And this is what I saw. In yellow here, we have the areas that do not have beavers. And then in blue, we have the areas with beavers. What you're looking at is a scaled difference in NDVI. So you can think about this like the percentage of maximum fire damage that occurred in a given area. And when we don't have beavers, the average is 0.58. So on average, these places are, they're experiencing about 60% of the burning that you could expect from a given fire. But if we have beavers, that number is much smaller. It's 0.19, so about 20%. And that's a big difference. So when you think about them in the context of each other, what we're seeing is that having beavers can help riparian zones burn 3 times less. They're 3 times more protected from fire if you have beavers in there working. If those little irrigation managers are spending year after year after year storing water and saving water and running it throughout the landscape with these channels, and doing it all for free, I might add. And that's huge, like 3 times less fire damage just because of beavers. And this is statistically significant, which is also important. So these are truly different values. These means, these averages are truly different. These data populations are truly different. And they're different at every scale. So then if I backed back up, and instead of putting all my data together, I just looked on an individual creek, or I just looked within a fire, it doesn't matter what scale I'm looking at spatially. Beavers fight fires a lot. These are all significantly different. The beaver dammed areas across the board are burning much less. And that's great. This is a repeatable phenomenon. I can confidently say that these areas are hard to burn, which makes sense, right? So here's a photo from the Mantor fire, which was taken by Brad Higgins, who was on the burned area emergency response team during the fire. And I'm pointing out there's a little beaver dam over here. So this creek has beavers on it, obviously. This one did not. And you can see scorched earth, flames that were able to completely engulf trees. That scorched earth trying to get into this beaver pond and failing. It couldn't burn all those wet plants. And so this is really cool. Here's another view of that same area. You can see the same rocky part on the side over here. The fire tried to come in and burn this area. We've got the beaver dam running through here, and it couldn't. It couldn't get in. And here's another area, or another view of that same area. Here's that rocky bit over here. And then what's really cool about this is there's actually this little hidden gem in this picture. There's something, a little black blob on this edge over here. So what is that? So here's another picture taken from the helicopter, and there's that little black blob again. Like, what is happening on the side there? Why is this so cool? It's because it's a black bear. And so this is excellent photographic anecdotal evidence that not only did the beavers preserve the vegetation, but the animals sought refuge here. And that when the landscape around them went up in flames, they went to the beaver pond and they survived. This black bear is alive. Well, probably not today because it's like 21 years later, but this black bear, it lived through this fire. And that's huge, right? Some of these species, we don't have that many of them left, and providing them with a refuge could be the difference between, survival or not. So the take home message there is, beavers are fighting fires. We hit this. There's 3 times less burning, it's staying green, and there's a lot of potential there to protect sensitive flora and fauna and preserve patches of vegetation to help attenuate post-fire debris flow. So now I'm sort of transitioning a little bit to my activity for us all. So where are California's beavers? Follow the sticks. So if you're looking for beavers in the field, the biggest clue is finding chewed sticks. So the sticks that beavers chew, they've got these teeth scrapes on them. And you can see all these little teeth marks. And that's how I find beavers, because you'll find these chewed sticks way far away from the dams. And that can tell you if you're even in a beaver area or not, well before you can see the water. And so I've got a few pictures. I'm just going to scroll through them for you to look at to get a kind of a feel for what these chewed sticks look like. That's me. They don't always chew through the whole log. So here they've kind of been like munching little chunks out of it. This is one where you can really see those teeth scrapes very nicely. They kind of come in at this characteristic angle. Here's some more where you can see the scraping. Didn't make it all the way through the log. They're still working on this. This was an active area. So you just follow these sticks, and you'll find the beavers. This is one that's actually pretty close to Santa Barbara. That's a little tiny toy beaver in my hand, making it chew on a little stick. So that's what I look for. You can find these, as I said, quite far away from the water, and they'll give you a good hint about if you're actually in a beaver area. The other thing to look for is the dams themselves. These are more obvious. They can be really big. They can be a little bit smaller. They can be teeny tiny. They can be very long, or they can be quite short. But if you find a lot of chewed sticks, you will probably find some dams. You can tell it's a dam and not a log jam because it's full of chewed sticks. This is one that's broken, but you can still see parts of it over here. These beavers have taken advantage of a little rock bridge that some recreationalists made in the national forest. And then you could do what I do, which is search from the sky. So I like to use satellite images to figure out where to even go in the first place, find the beaver pond, and then go scout it out on land. So in general, when you do that, you look for linear or curvy features spanning your river or creek. You look for ponded water, which is a big dark blob. By that feature, you can look for the channels, and you can look for that lodge, the circular beige blob. And so if you remember, I showed you one of these all mapped out before. Lots of beaver dams, lots of beaver channels, and a beaver lodge in this image. But I'm going to show you a few more to give you a little bit of a feel for it, and then we're going to test your skills. So here's that one from the Manter fire that I pointed out. And in it, I can see definitely a lodge here in the middle. And there's quite a few beaver dams around it, which I'm now going to highlight for you. And so you can see, again, one beaver lodge, one beaver family supporting quite a bit of beaver activity and beaver damming in the area. Here's another one. Remember, we're looking for kind of curvy linear features, these big dark spots, which are the ponds themselves, and then channelization throughout the landscape. So little channels radiating out from these ponds. This one's interesting. It's in Colorado. It's an extremely heavily dammed area. I've now highlighted all the beaver dams for you. There's many families maintaining this, but this is a massive amount of beaver damming. Pretty incredible. You don't see this too often in California, but it does happen occasionally. And so then here's another one. It's got only a couple of beaver dams in it. This one's pretty far up north in Canada, but you can see even in this area with not that much water, there are a couple of beaver dams. You can see these channels radiating out from them. That dark patch behind it is the pond itself. And so this is how you find beaver dams, using Google Earth, using Google Maps, and then you can go on the ground and start searching for those chewed sticks, start searching for those dams. It takes a long time to walk the entire length of the river, so why not start out by finding an area where you're pretty sure there's a beaver dam and, digging in from there. So now I'm going to switch over to a different window and we're going to practice finding some beavers. So what I'm going to show you, it's a poll everywhere. Some of you may have done this. Some of you may have not. This is so you go to pollev.com/EmilyFairfax433. You can do it on your phone or your computer. And I can only take 40 responses per example. And we've got like 8 of these to flick through. So if you answer on this one, maybe don't answer on the next one to make sure everybody gets a chance. So what I want you to do is go ahead and go to this website, pollev.com/EmilyFairfax433, and then tap on a sign of beaver that you see in this photograph. If you see a sign, remember the signs we talked about. So this is on the ground. We're looking for chewed sticks. We're looking for dams. We're looking for lodges. So go ahead and tap, and I have it set right now. So we're just looking at the image, and then I will, in just a second, flick it over to responses, and we'll see where everybody tapped and talk about it. All right, so let's see where we're at so far. All right, so lots of good things being seen here. Very clear signs of beaver. See those pins dropping? Excellent. So I'll flick back over to the image real fast. We have lots of things going on. Many of you have found this, which is the beaver's lodge. It just looks like a big old pile of sticks, but it's got that kind of characteristic mound shape, and it's covered in chewed sticks. Many of you, it appears, are also finding chewed sticks, which is great. Follow the chewed sticks. That's literally the best evidence. There's a big cluster of them over here, and then throughout the pond, there's quite a few sticking up. I don't think anyone's grabbed it yet, but there's a little one right here in the very front. So lots of chewed sticks, definitely a lodge, and then also there is a pond here. Ponds can happen for lots of reasons, but in this case, this is 100% a beaver pond. So now let's go on to the next one. So it's loading up the image for us. So how about in this one? So again, I can take 40 responses, tap or click on any sign of beaver that you can see. And remember, if you're on your phone, you should be able to do the little pinch and zoom. If you're on your computer, you should be able to like do a scroll zoom if you need to look in a little bit closer. These are going to get a little trickier as we go. So look around, look for signs of beavers. This one's up in Wyoming, very beautiful site. See what people are thinking so far. Yeah, lots of beaver signs in this landscape for sure. So many of you have cued right in on over here. So this is another cluster of these chewed sticks. I swear, every time I go hiking, it doesn't matter who I'm with, I always wind up weirding out my hiking companions because I like stop and look at every single stick I see on the ground. And I'm like, look at this stick, look at this stick, because I'm looking to see if they're chewed on. And over time, people get used to it, but it's always a strange moment when I'm out hiking with someone and they're like, wow, why does she keep looking at every single stick we pass? Sticks aren't that interesting. They are that interesting. Many of you also found this feature here. So here's actually the dam. This is a very old beaver dam, so there's lots of vegetation actually growing on it. Once vegetation starts growing on the beaver dam, it's more likely to become a permanent landscape feature because those plant roots kind of hold it in place even as the beavers come and go. We've got the pond itself. We've got some chewed sticks floating throughout the background here, more chewed sticks back here. There is some channelization that you might be able to see kind of creeping out into the background. So great job on that one. How about in this one? We're again on the ground, lots of evidence of beaver here. Have it just on the image so y'all don't get it spoiled for you if you're taking a minute to look. This is also Wyoming, very cool site up by Laramie, tons of beavers up there. All right, looks like we filled this poll up, so let's see what we found. Lots of great things here. So many of you have cued on to this sort of pile of sticks situation. This is actually part of a beaver dam that again has large amounts of vegetation growing on it. A little bit over here as well that you've seen. This that we're looking at here that a couple of you have picked up on, this is a classic beaver channel. So the beavers have dug these channels out from the main waterway so that they can move into the landscape and help drag those sticks up and down as you go. So now it's a little trickier. Now we're in satellite images. This is one up near Lake Tahoe. So remember, you're looking for curvy and linear features. You're looking for those really large dark patches, which are the pond. You're looking for sort of channels radiating outwards from the ponds. Can you see any beaver dams in this image? If you see a beaver dam, go ahead and tap or click on it. And I can tell you right now, there are several. It'd be pretty rude if I just put up an image and there were no beaver dams in it. So let's see how we are doing. Excellent. So some really great findings. Many of you queued on to this big one right here in the middle. Now I will point out that while we have this big one here that I'm going over with my little laser pointer, we also have another one right below it. You can see that kind of curvy linear feature that spans bank to bank. We also have one up here and here and here and here and here and here and down here. Lots of beaver dams. So usually you don't find just one, you find several. Here's another one for us. These are out near Victorville. These are all California examples. I tried to keep it on theme. Few dams in this image. A little trickier because you've got some pretty heavy tree cover, but I can see at least 3 right now just looking at it. So I'll give you a second to try to cue on and see if you can see any beaver dams. These beavers are kind of cool because these are really out in the desert. Like there's some creeks that run through the Mojave and there's beavers on them, and they maintain these gorgeous lush wetlands despite the fact that they have exceptionally low amounts of precipitation. So a lot of these beavers are accessing some of what's called mountain block recharge, water that goes in on the Sierra Nevada mountains and travels through groundwater only to spring up down by its base. These beavers have taken advantage of those springs and built some dams. Let's see if y'all could find some. Lots of good things over here. So many of you queued onto this one. Very true, definitely a beaver dam. Also, many of you queued onto one up here. Let me flick it back to the image so we can see. So up here, beaver dam. Down here, beaver dam. We actually also have a beaver dam right here. A little beaver dam in here. And I don't see any on this side channel. However, I do believe that these channels are hydrologically connected by beaver dug channels. So lots of beavers in that image. Lots of beavers in the desert. It's pretty sweet. Here's one that is near Temecula, between LA and San Diego. So beavers are not just mountain critters. They come all the way down to the coasts. See those responses plopping in. A couple of beaver dams in this image. Many of you are queuing onto. Let me flick it back to just the image itself. So this is pretty cool. San Diego State University has like ecological preserve, and on that preserve are quite a few beavers, which is pretty neat. Let's see what we found. All right, so lots of people queuing in right here. This is our biggest beaver dam in the image. There's also one right up here. And then we flick back to the image itself. This one has some distractors. So here and here and here, it looks like we have more ponds, but these are tree shadows, which is the worst. I really love studying beavers in the desert because there's no big trees to cast shadows. These are horrible distractors, but they do happen a lot. So when you are searching in your satellite images looking for these beaver dams, watch for trees. If all of them are going at the exact same angle, chances are it is a tree shadow and not a beaver pond. This is a cool one. These are some beach beavs. So this is in Pismo Beach. We've got some beaver dams happening right up all the way to the coast. Beavers are not deterred by brackish water or estuaries. They will go ahead and keep on damming. So if you see a beaver dam in this image, this is going to be hard because we've also got dunes with lots of foot trails, which may be confused for beaver trails. We've got an estuary, which is an inherently complex wetland even without beavers. But in this one, there are some beavs. And it looks like y'all are doing a great job finding them. So right up here, we have a main beaver dam. Let me flick it back over to the image. Over here, we have a beaver dam. Here we have some more beaver dams, beaver pond in here. Tragically, this image is from several years ago, and since this point, beavers have not been as welcomed in Pismo Beach. However, they do still live there. They just have less dams. And so we'll do one more of these. This is the last one that I wanted to do today. So this is some more beaver dams. Whoop, it went backwards, I think. Go forwards, go backwards. Odd. Well, I don't know where it went. I had one. You all did a great job. You did wonderful finding all of those beaver dams. The last one was some beavers that are also in the desert up by Atascadero. Pretty cool beavers. So I'll flick back over real fast just to my slides so that I can pop up a little bit of my contact info and take any questions in the 3 minutes that I left us for questions.
Thank you so much. I am sharing the poll results if you guys want to click on your poll. And it looks like a lot of us have heard rumors. We're not sure how to find them, and we know how to find them now. So that is fantastic. Thank you. We've got a couple questions. I know Butterfly O'Shea had a question about, do they actually eat the wood?
That depends on how you define the wood. So beavers like the bark and the layer between the bark and like the tree core. It's very sugary. And so that's what they try to eat. But if it's a pretty narrow stick, they do kind of just eat the whole thing. It's very fibrous. And so one of beavers' adaptations for that is they eat the stick once, it comes out the other end, they eat it again, they digest it more, and it comes out again, and then they're done. They're not gross. They don't do it more than once. But yes, they do consume trees.
Is that coprophagy?
Yep.
Awesome. I won an extra credit point on a test in college for that once. Emily, I think everyone would like to know how to contribute to your work. Are you monitoring iNaturalist? If people find beavers, is there a way to share that information with you?
Yeah, iNaturalist is great. I go on there fairly often to find beavers. It's one of the ways that it's a line of evidence I use when I'm looking at satellite images to try to figure out if this is a recent beaver dam or not, or if it's still active. I see if anybody has seen beaver activity in that area. So iNaturalist is huge. I also go in constantly the California beaver observations and confirm or deny them pretty quickly. So if you post one, I will find it and I will evaluate it. Yeah, that'd be a great way, because a huge part of my work is just finding the beavers. And the more people out there with their eyes peeled looking for them, the easier that is.
Great. It looks like there's some confusion about how widespread beavers were in California before the European settlement. Do you have any information on that or an opinion?
They're super widespread. Great paper came out in 2013 about it, poured through the historical literature, poured through trapper journals, looked at native languages, looked at landmarks, looked at zoological specimens, looked at pictographs. Beavers were quite widespread throughout California. They existed naturally, natively in essentially the entire state, save for a couple of patches of desert in the southeast. They went all the way down to the coast. There's Chumash pictographs of beaver. There's words for beaver in 62 native languages. So definitely native throughout the state. Unfortunately, trapping took them down to near extinction. And then the term I've heard used for it is ecological amnesia. So a lot of folks have just forgotten that beavers belong here. And so they feel invasive, even though they are not.
Interesting. What about beavers in nutria? Do they have habitat displacement? Is that a possibility?
Nutria, bane of my existence. Nutria are not native. Nutria, the number of times where I have given an interview to a newspaper and then they run the article with a picture of a stinking nutria is so high. Nutria are actually much smaller than beavers. Nutria do not eat wood and trees in the same way that beavers do. And so while you may find nutria hanging out in beaver ponds, beavers are not particularly threatened by nutria. Nutria threaten a whole lot of other species, so they're definitely an invasive issue. But beavers seem to be able to exist without much hindrance.
All right. There's lots of other questions. I'm sorry we can't get to them all today. They're good ones. If you have information, feel free to fill in information in the chat, folks. I want to thank you, Dr. Fairfax. That was super inspiring and really fascinating. And I know that a lot of people are going to go back and watch the video too. We shared the link to your stop animation film in the chat. So thank you all for participating today. We hope to see you again. We really want to know more about you, hear about what you want to hear about, and your ideas moving forward with this CalMap series. We put an evaluation link in the chat, super important, please fill it out. Coming up, we've got a full slate of presenters this year, soon to be announced. Claudia Diaz Carrasco is our 4-H Youth Development Advisor, and she's a CalNat instructor for the Southern California Mountains Foundation at the Urban Conservation Corps in Inland Empire. Sorry, that's such a mouthful. And she's going to be presenting on February 23rd at noon, and she's going to be talking about ensuring the cultural relevance of environmental education. So if you can't make a presentation, you can always register to receive the link directly on our, we have it on the YouTube channel as well after the presentation. So it's great to see everyone. And thanks again, Dr. Fairfax. We really appreciate your time. And thanks everyone for joining us today.